All right, everybody, I'm going to talk through the balancing and classifying review. So in that Monday folder, there's a folder that says, I assume you know this. And that's going to be the notes about entry one stuff. Get a good handle of that. I know it's been a couple weeks for us, but it is the foundation for what we're going to start on Wednesday this week. So today's just some practice, and tomorrow you got two online quizzes to complete that are 5 points each. So the first part is to identify our reactions. Remember, we got 5 parts here. There's going to be one of each: synthesis, decomposition, combustion, single replacement, and double replacement. And there's a key to identifying each of these. I would check your answers for set 1 here, and then if you have to, go on to set 2. Problem 5 for both of these is a little bit harder. You will need your periodic table, which is going to be right at the top of our Schoology page, just in case you don't have a physical copy. So, and there's first problem. You got magnesium, and you got HBr. So magnesium is an element, and hydrobromic acid is right here. That's a compound. Notice that the metal switches spot with hydrogen. So I get an element and a compound on both sides, ionic compound and element. That tells me that this is single replacement. Okay. Number 2, I got one reactant telling me it is decomposition. Okay. I'm going to just do that. Okay. Number 3, I get one product. Notice I got 2 elements, and in entry 2, that's going to be a big key for us here, telling me that that is synthesis. 4, I got 2 compounds here, KCl and H2CO3, potassium chloride, and carbonic acid. And then the K and the H switch what they're attached to. The K goes with CO3 over here, and H goes with Cl. That is called double replacement. And then the last one, which if you can't, if you struggle to write the compounds, that's fine. Dicarbon tells me you got 2 carbons. Tetra means 4 hydrogens, so it's C2H4. Remember to leave space to balance. And plus, I'll leave space to balance. Oxygen, which remember, oxygen's a sneaky 7, so when it's by itself, it gets a 2. Notice that sodium is not a sneaky 7, so it does. F is a sneaky 7, so it does. Same with lithium. Not a sneaky 7. Oxygen, sneaky 7. Hydrogen, sneaky 7. Magnesium, not. And then that's going to make carbon dioxide. So CO2 plus H. Wow. That sucks. Apologies for those technical difficulties. I hope it wasn't too much of a distraction. So here I get a carbon compound and oxygen making CO2 and water, which tells me that is a combustion reaction. Okay. So there's one of each type. Now for balancing, remember I just got to go back and forth. So I'm going to go back up to number 1 here. So I got 1 magnesium over here. I get 1 magnesium, so I'm okay there. Here I got 2 Brs. There I only got 1 Br, so I got to put a 2 out front. Remember, you multiply. So I got 2 H's and 2 Brs. I got 2 H's, 2 Brs. That's great. All these are blank or 1. Remember, the blank tells you that there is 1 of each of those. Okay, so you don't have to write 1s. So simple balances here to start. I got 2 F's, 1 F. So I need a 2 here. That gives me 2 NAs. So I got to put 2 NAs on that side, giving me 2 F's on both sides. I need a 1 there. Okay. Here, I can already tell you that I'm going to have to put a 2 there to balance my oxygens. 2 times 1 oxygen gives me 2. 2 times 2 gives me 4 lithiums. So I need a 4 there, and then 1 O2. Here I got KCl and H2CO3. I got 2 Ks, so I need a 2 on this side. That gives me 2 Cls. I need a 2 on that side. 2 H's, 2 H's. Remember, I want to treat carbonic acid, or sorry, the carbonate as one item. You see how it's the same on both sides? I'm going to leave that there so you can kind of see that that's separate. And then I need 1 of each. Now remember, the last rule for balancing for combustion specifically is if I end up with an element in two spots on one side, such as oxygen and oxygen, I'm going to do it last. So in combustion, you can think about doing it in alphabetical order. C's, then H's, then O's. So I need 2 C's there to balance. Then I'm going to need 4 H's, so I got to come over here and put 2 there to give me 4 H's. Now I want to add up all of my O's on this side. So I get 2 times 2 is 4 O's. Then 2 times 1 gives me 2 O's. So I got 4 plus 2 give me a total of 6 oxygens. So on this side I need 3. And then this is going to be a 1 or blank. And there you go. That's our first problem set. So if you have to pause and set up a time with me to ask some questions. Otherwise, you can try the second problem set and move on, which I'm going to do right now as well. So in problem set 2, feel free to pause and then come back and fix some things here. I get combustion for my first one because I get carbon compound and oxygen making CO2 and H2O. I get one product on this side that is synthesis. I'm just going to space it out so it's easier to see. 3, I get one reactant, so that's decomposition. 4, I get an element and a compound on both sides, that's single replacement. And 5 will be double replacement once I write it out, which is going to be kind of a pain in the butt, but we'll get there. Okay, so I'm going to pause the video quick. Actually, I'd take it back. I'm going to do it just so you get a sense, because we got to write products in the future. So here I get cesium chloride. Cesium is a CS, it's a +1 charge. Chlorine is Cl, it's a -1 charge. The plus and -1 charges actually cancel out. That's an ionic compound. Magnesium is a +2. Okay? And nitrogen is a -3. So that means that nitrogen's -3. I'll just show you here. And magnesium's +2. Oops. They are going to crisscross. So the 3 from nitrogen will come down to magnesium. So it's going to be Mg3. And the 2 from nitrogen or magnesium is going to go down to nitrogen. Okay, so then this ends up giving me my formula of magnesium nitride. Okay, ionic compounds you crisscross, and I know it's ionic when I have 2 metals. And actually what I'm going to do here is I'm going to copy and paste this on the other side. So now cesium is going with nitrogen. Remember nitrogen was a 3. So that 3 from the nitrogen is going to end up on cesium, and the 1 from cesium is going to end up on nitrogen. And then magnesium's a 2, but it's crisscrossing with chlorine, which is a -1. So the 2 from magnesium goes to chlorine, the 1 from chlorine goes to magnesium. And then that's going to give us my products. So that's a double replacement reaction, 2 ionic compounds on both sides. All right, so now we're going through to balance. Remember combustion, I get oxygen in 2 spots on this side, so I'm going to do that last. So I'm going to put 5 there to balance my carbons. And 5 carbons, 5 times 1 is 5 carbons. We're about oxygens later. 6 hydrogens, 12 hydrogens, so 6 times 2 gives me 12 hydrogens. Now I got to add up my oxygens on this side. So 5 times 2 is 10, 6 times 1 is 6, so I have a total of 16, giving me 8 oxygens. Remember, we could have put a 1 here or blank. So I'm going to put a 1, and then I'm going to delete it just so you can see where that's coming from. Because technically you won't write 1. So up here, none of those 1s are written. So I didn't write 1s this time, and I'm going to make a note of that up here. I did not write 1s when I balanced. Wow, typing is hard. So here, calcium's 3. Nitrogen's 2, nitrogen's 2. So all I have to do to balance actually is put a 3 here. And then it's going to be 1 and 1. But since I don't write 1s, I can just leave it blank. Hey, here I got 1 barium, 1 oxygen, 2 oxygens. So that's telling me that I'm going to need a 2 here. But that's going to now double my barium, which is 2, give me 1 oxygen. So just a 1. Okay. 1 calcium, 1 copper, 2 chlorines, 2 chlorines. This one's actually balanced as is. It's all 1s. It's all 1s. Okay. Come down here to balance my last problem. hate those bonus pages. All right, so I could start anywhere. I'm going to start with cesiums because it's my first element. 1 cesium, 3 cesiums. That tells me that I'm going to need a 3 here. Now, just because I put that doesn't mean I won't have to change it. That gives me 3 chlorines. Here I got 2. Okay, so now I'm already seeing that these things are unequal. So 3 and 2 have to be 6. That's the first number they will both go into. So to get an equal number of chlorines, I got to put a 3 there to give me 6. But now I need a 6 over here to give me 6 chlorines. 6 cesiums going to give me a 2 cesium. And then 3 magnesiums, 2 nitrogens, 2 nitrogens. This one's actually just a 1, so I can delete that. Now, if you get stuck on a problem like that, start by trying to balance in a different spot. So say you got stuck. You're like, all right, I don't know. I'm going to start with magnesiums now. I'm going to go to the next metal. Magnesium's a 3, so I need a 3 there to give me 3 magnesiums. That gives me 6 chlorines. So right here, I need 6 chlorines. Need 2 nitrogens. So right here, I need 2. That's a 3. 2 nitrogens, and then 3 magnesiums on both sides, and so forth. So you see how starting in a different spot gave me the correct answer a little bit easier. So sometimes starting in a different spot, especially on these double or single replacement problems, or even synthesis and decomposition, can help you as well. So I might reformat this a little bit so it looks a little cleaner, but otherwise the key is posted. It's the same. So tomorrow your quiz is going to be 5 identifying and then 5 balancing. All right, guys, good luck, and let me know if you have questions.